go. Everyone should have got the notification. All right, exponential functions and models. So our goals to get today are to distinguish between linear and exponential growth, recognize exponential growth and decay, calculate compound interest, use the natural exponential functions in application, and model data with exponential functions. All right, so just to review what a linear function is and the properties of the linear function, f of x equals x, all real numbers is the domain and the range, the intercept is at 0, 0, and as x increases, y increases. We all remember this guy, right? Now, our exponential function. So our exponential function is a little different. With our exponential function, we are growing rapidly, and it's increasing forever from left to right. It's not decreasing. There is no minimum. The domain and range are structured a little different. So the domain, that's not how you spelled it. I'm just going to start with the range then, so I spelled it. Because there is an asymptote at y equals 0, our range is from 0 to infinity. However, our domain has no discontinuities, so our domain is from negative infinity to positive infinity. Okay, and we do not have an x-intercept because we do not touch 0, but we do have a y-intercept, and our y-intercept is at 0, 1. And that's because anything to the 0 power equals 1. Okay, so that's our parent function for the exponentials. If you click on your notes that are posted on your Brightspace, there is a detailed difference between linear and exponential functions. We are not going to dive that deep, but I wanted you to have access to that if you wanted to do a little research. Linear functions are increasing or decreasing by adding. Exponential functions are increasing or decreasing by multiplying. Make sense? Okay. And it says adding and multiplying because subtraction is just adding a negative. Agree? And division is just multiplying by a fraction. That's why we only use the words adding and multiplying, because you can interpret the other two with them. Questions so far? Okay. So to identify the change is we're going to look from one number to the next. If I added the consistent number, then that's a linear function. If I multiply from one number to the next, then that is exponential. So let's analyze these two tables. So analyzing these two tables, I'm going to ask myself, how did I get from 10 to 7? How did I get from 7 to 4? So what did I do? I added -3, right? How did I get from here? I also added -3. Because I'm consistently adding the same number, that means that this is a linear model. How did I get from 2 to 6? I multiply by 3. How did I get from 6 to 18? I multiply by 3. Because I consistently multiplied by the same number, this represents an exponential model. Do we see the difference in the tables? See the words come to life? Okay, so to find the model that represents it, you're just going to say how did I get there? So for linear, remember our model is y equals mx plus b. So for this problem, when I write its function, its model, its equation, your m is your constant change. And what was my constant change? -3. And your b is your starting value, your value at 0. And what is my value at 0? So that is my representation. So then let's talk about exponential. So exponential is a little different. Your exponential is based off of it's y equals b a to the x. Okay. And your b plays the same role. It's your value at 0. So just how our b here is our y-intercept, our b here is also our y-intercept. So our y-intercept, and then what we're growing by. What are you changing by? So in this case, what is our y-intercept? 2. And what are we changing by? And so this would be our model. How do you feel? Doable? Okay. And I like to do it with the B, but not every book or instructor is going to do it with the B. The reason why I use B is to kind of get you in that mindset that what did B represent here? Your y-intercept. So what is B representing here? Your y-intercept. Does that make sense? So I'm going to show you that not everyone, textbook switches it. And I think this one does also. An exponential function is a function in the form of a times b to the x. So notice how they switched the a and the b. They put b as the base and a as your y-intercept. So, to find your a, you look for when x equals 0. So f of 0 equals a. To find b, divide the y values of 2 points, which is what we just did. Oh no. You never saw anything. Okay. So here we are. So to find the values for c and a so that f of x equals c times a to the x satisfies the conditions. Okay. So when I look at this problem, remembering even though the variables have changed, c comes from f of 0 and a comes from y2 divided by y1. Okay, so let's begin to find those parts. On the first one, so c is our f of 0, and what is f of 0? 6. So we know that 6 is our c value. If I have f of 0 equals 6 and f of 1 equals 3, that means that this is my y1 and this is my y2. The reason why this is my y1 is because 0 comes before 1. So to find my a, it equals my y2 divided by my y1, which is 3 divided by 6, which equals, he meant 1/2. So putting it all together, f of x equals 6 times 1/2 x. How do you feel about being able to do that? Can you identify and can you divide? All right, let's see. So notice here on this one that, are they giving me my f of 0? No, they do not give me my f of 0. So I'm going to have to do a little bit more work. Huh? Just a little. It's not going to hurt you. Okay, so on this one, we're going to find f of 1 divided by f of -1. Okay, and what do we get? We get 1 divided by 1/9. And what is that? Anyone? Everybody? It would be 9, right? So we would get 9 there, right? Now, this is not right after that, right? So there's a number in between there. And so to find our y-intercept, we're going to use the information that we have to solve for our C. So if I know that this is my X and this is my Y, or this is my X and this is my Y, and I know what they equal, you go to voicemail. I'm going to plug in and solve for C. So I have 1 equals C. I don't think I should have used this number. I didn't think it'll work. I'm forgetting a step, y'all. I just had a brain fart. I should have erased it. I should have erased it. What am I forgetting? Because when I plug in this 1, it's just going to give me C equals 1. OMG. We're going to do it table way. Yeah. I don't know why I'm having, who knows? We're not even going to blame anyone but myself. We have -1, 0, 1. And we're at 1/9, and we're ended up at 1. So how am I getting from here to here over the course? Well, we know between these two that this is 9, and I have 2 smaller pieces to get to. So therefore, this has to be 3. And there's a mathematical way of showing it, but I'm having a brain fart, and I can't tell you the other way. Why? But here, so you know between these two is 9, and this is squared because it's multiplication, is exponential. This is going to end up being 1/3, and 1/3 times 3 is 1, and that's how we find the pattern and figure out what our A is. This is not it, but we know that A equals 3 by analyzing the table. Without analyzing the table right now, I don't know what to tell you. But we are going to use the table. That makes more sense in my mind. So using the table, we know that from 1/9 to 1, that's 9. But in between, something had to happen. And in between is our 0. And so by using the table and finding the pattern from the table, we can find our A and we can find our C strictly from the table. I don't know why I was doing the math. There was something that I was going there with it. Don't remember it. But I can tell you by table. So by table, do you see where your C and your A come from? What I was doing around it, I don't know. I'll get back to you though. Hey. Sleep deprivation, it's not healthy. Question about by table though. So the 3. So on the table, you're going from -1 to 1, and you know that's going to give you 9, right? But in between, what's happening? Well, you're multiplying, so it would be the square root of 9 is how to get from one to the other, because it's multiplication, and you're multiplying by the same number, so you would take the square root to figure out what is that number I'm multiplying in between by. So to get from -1 to 0, my next actual step would be to multiply by 3, which gives me 1/3. And then to get to my next one, 1/3 times 3 gets me to 1. I feel like there is like an actual process without the table. I started doing something here, and then I had a brain fart. Yeah, I was on a path of like, oh yeah, I'm gonna do this. And I couldn't remember where I was going with it. But there is a math way without using the table. But the table is also always there, and the table is pretty straightforward. Right now, I'm just gonna say the table because, yeah, I'm gonna put a pin in it. I didn't mean to do that. But do you understand the table? That's the question. Yeah, so it'll be a number that you can square. Remember, you can square anything. Fractions count as part of taking the square root of something. So if it was like 6 from one to the other, I wouldn't give you that to do by the table. But you're going to take the square root. I know that much. I'll figure it out in my brain. We'll come back to it. My brain is having some weirdness. At the end of class, I will be back. I do. I haven't had any liquids this morning. I have not had any liquids this morning. I'll drink some later. I've had a granola bar and a banana. A sample of bacteria doubles in concentration each day. The initial concentration is 1.5 million bacteria per milliliter. Find a function that gives the concentration of bacteria after X days. Estimate the concentration after 4.5 days. So you're going to figure out what's your A and what is your B based on the problem you read. So we have f of x equals a times b to the x. So I can stick to what your book is going to tell you. Okay, so your initial represents your A, right? And it says my initial concentration is, so A equals 1.5. Does that make sense? And how is it changing from one to the other? It doubles. So mathematically, what does doubling mean is happening? By 2, right? It's multiplying by 2. So therefore, your function is f of x equals 1.5 times 2 to the x. That's not an x. So just reading the problem and pulling out those things. Initial, doubling. That's how you are going to write the problem. And now it wants us to estimate the concentration after 4.5 days. So we're looking for f of 4.5. So I plug that in, 1.5 times 2 to the 4.5. So in your calculator, how do you put it in the calculator? It won't open. Didn't we use my calculator last week, y'all? And I had it going and it was all good. I know we had this calculator. I know we used it. Let's try it again. There it is. Sorry, my calculator decided that it wasn't going to be a calculator today. And I had to show who's boss. And all right. So again, in the calculator, you're just typing 1.5 times 2 parentheses 4.5. So that's inputting it into the calculadora, hitting enter, and you get 33.9 million. So after 4.5 days, there will be 33.9 million bacteria. How do we feel about that word problem? Good? All right. Next, transformations of exponentials. So just remembering your left, right, your up, your down, it does the same thing. So if your A, if it's negative, it's an x-axis reflection. Depending on your A, you have a stretch or a compression. If A is greater than 1, A greater than 1, that's a stretch. If the absolute value of A is less than 1, but greater than 0, that's a compression. Your C, that's telling you, remember our X is a liar. So if it's minus C, you're going to the right. If it's plus C, you're going to the left. And D is your negative down, positive up. And your domain is all real numbers. Your horizontal asymptote depends on your D, and your range depends on your D. Okay, they're in different positions, but the variables are the same for all transformations. So let's start here. Explain how to obtain the graph of G from the graph of f of x equals 2x, then graph both f and g in the same xy plane, okay? So here we have g of x equals 2x plus 1. Now what's happening here is, I'm going to show it with the table. I am starting off with 2x. So starting off with 2x, so starting off with f of x, I have values of 2x. So if I am using negative 1, 0, 1, I don't know, 2. If I plug negative 1 in, that just means I have 1/2. I plug 0 in, I get 1. I plug 1 in, I get 2. Plug 2 in, I get 4. Does that understand where we're getting those values from? Okay, so now what g of x is saying is that each one of my x values are going to go to the left 1, but my f of x isn't going to change. So I'm taking this table and I am shifting each x value to the left. So I'm subtracting 1 from each x value, and the y values are going to stay the same. So for g of x, these are going to be the same. What's going to be different are the x values. So if I subtract 1, subtract 1, subtract 1, subtract 1, where is its new home at? Well, this new home here is going to be at negative 1 minus 1 is 0. No, negative 2. Negative 1, 0, and 1. So at negative 2, I'm now at 1/2. I don't know what happened there. I just wanted to make a dot. Okay, let's try that again. 10. At negative 2, I'm at 1/2. At negative 1, I'm at 1. At 0, I'm at 2. At 1, I'm at 4. That's all that changed. I don't have a change in my D, so I still have my horizontal asymptote at y equals 0. And so now I'm going to do my very, very best to connect and curve. So you can do a transformation just from modifying the parent function, but without graphing it. And it's just simply following what the transformation means. So because I know that this means I'm going left 1, that means to all my x values, I had to subtract 1. This one right here, this negative 2x, that means I'm reflecting over the x-axis, right? So this is an x-axis reflection. And if I'm reflecting over the x-axis, is that affecting my x's or my y's? My y's. If I'm reflecting over the x, that's going to affect my y's. So every y value of the parent function is being multiplied by negative 1. So when I would graph this g of x, I'm going to do it in a different color. This time, my x's are staying the same. So I'm still going to have -1, 0, 1, 2. But my y's are what's changing. My y's are each being multiplied by -1. So it's going to become -1/2, -1, -2, -4. So when I graph this, where am I graphing it at? Am I using the same graph? I think I am, yeah. I was like, I thought I was going to erase it, but do I erase? Do I not erase? Is it okay if I graph it on the same one without erasing? Will that bother anyone? No? Okay, cool. So I'm going to graph here at -1/2, -1, -2, -4. And that would be my other g of x. How do you feel about being able to do a transformation from a table or just from understanding what's happening to the parent function? Remember, all transformations come from the parent function. Okay, it's like it's their babies, their children. It all starts with them, and then all the changes and come afterwards. But you're manipulating the parent function. Yeah, it puts it in the denominator. Mm-hmm. If you what? If it was a negative? It's the fact that it's negative. So if I have 2 to the -1, that just means 1/2. So remembering those exponent rules. All right, next we have compound interest. It's a formula. May want to write it down. You may need it, especially for your quiz. So compound interest formula, including principal. We have A equals P, which is our principal, times 1 plus R over N. R is our interest rate. N is the number of times it will be compounded per year. So if it says quarterly, how many times would it be compounded? 4. Quarterly means 4. If it said annually, that's 1 time, right? If it said monthly, that would be 12 times. Does that make sense? And then time of year. So how long is this going to be happening? Is it a 1-year loan? Is it a 2-year loan? Is it a 3-year? Is it 36 months? Well, that's 3 years. But you get what I'm saying. Okay, cool. Did we all get the formula? Now, sometimes when we have what's called simple interest, so if it's a simple interest, and am I spelling interest? Yeah. All we need is A equals P times 1 plus R to the T. And this is mainly when it says annually. So if it says annually, that's your key that you're dealing with the simple. Can you still use this one? Yes, it will come out the same answer, even if you use the full-on compound interest formula. And the reason why is that in this case, when it's annually, your N is just 1, right? And so there's no point of having N or using N because it's 1. So let's do an example. So we have here, if the principal is 1,500 and the interest rate is 7%, compound annually, calculate the account balance. So again, this one lets us know that it's an annual compound, so we can use the simple, which is A equals P times 1 plus R to the T. And we have to just identify all parts. What is our P? 1,500. What is our rate? 0.07. And what is our T? 10. And we plug everything in. So A equals 1,500 times 1 plus 0.7 to the 10. The what? Because it says annually, our N is 1. And that's why we don't have to use it. I mean, you can write it. It's not going to affect anything, but it's a 1. So I go to the calculator, 1,500, parentheses, 1.07. And I'm going to get the carry to the 10 power. That's a 4. And I hit enter. And how much has my money turned into? $2,950.73. 73 cents. How do we feel about using the formula? Good? Okay, are we ready to do another one? Here you go. Suppose $2,000 is deposited by a worker in an individual retirement account, an IRA, that pays an annual interest rate of 6%. Describe the effect on the balance after 30 years if interest were compounded quarterly rather than annually. So you're actually going to use both. You're going to do the simple and you're going to do so that you can compare. If you only do one, can you compare? So how much money did he make annually if he compounded annually? 11,486.98. How much did he make if you compounded quarterly? $11,938.65 is what I was looking for. So comparing the two, which one is the better? Quarterly. If he compounds quarterly, he's going to make $450 plus more dollars, right? So when I compound quarterly versus annually, I'm actually increasing my money faster. So approximately 451 more quarterly. So do we see the difference between the two? Questions, comments, concerns, my friend? None? All right. Next, we're going to talk about approximating using the calculator and just kind of making sure you're comfortable finding the mode to help you with your rounding. So notice here it says 3 decimal places. So with the calculator, you want to make sure that if you're not strong at rounding, you see this button right here that says mode. You want to take it from float to whatever it's asking you to round to. So if it's asking me to round to 3, I'm going to turn on 3. And this setting will go throughout the whole calculator. So it will be the setting for your table, the setting for, so if I have y equals, and I'm going to put in 2, and I need second natural log e to the negative 0.05 x. And I hit graph. I either can analyze it from the graph or I can analyze it from the table. If I'm analyzing it from the graph, I hit second, trace, and I type in 1 where it says value, and I type in what it's asking me for. It asks for 1.2, hit enter, and it tells me that's 1.884. Okay. Then it says, what is -4? I hit second, trace, value, and I type in -4, hit enter, and it tells me it's 2.443. I'm not going to write out the steps for the calculator. I feel like you also can do this without these little tricks, but can't say I didn't show it to you, okay? The other option is to use the table. If you choose to do by table, you have to change your table settings, and you go to the table setting and you switch it from auto to ask. So you switch it from auto to ask, and then you type in whatever you want. I want 1.2. I want -4. And it will produce the answers. Okay? So this will be our stopping point. We will pick up at continuously compounding tomorrow.